Hello my friends again, and welcome to this fourth video into which we are going to carry on answering questions of Pearson Edison International GCSE syllabus and the 2024 questions, 17th of May. Subject is chemistry. As we said before, my friends, we answered questions 1, 2, 3, and now my friends, let's go to answer question number 4. Question number 4 is about the alkali metals. I'd like to remind you that the alkali metals, my friends, are metals of groups 1 and 2 in the periodic table. A teacher demonstrates the reaction between sodium and water. The teacher fills through trough with water and then adds a piece of sodium. As you see, this is the trough here, and this is the piece of sodium, and of course this is water here. The sodium reacts with the water, forming bubbles of hydrogen gas. Here, the bubbles of hydrogen gas, and a colorless solution. State 2 observations that would be made. In here, my friends, we've got a lot of observations we can mention. Generally, when the question is theoretical, I'd like to use the scheme to answer the questions because there are no calculations, nothing, let's say, to use our IQ to answer, just theoretical things that should be memorized. So we have observations here. I have written 1, 2, 3, 4, 5 observations. The first one is the sodium melts into a ball or a sphere. As you see here, this is a kind of a cube in shape. So when we put the sodium on water, it's going to be like a ball, and this ball, spherical, is going to move quickly on the surface, and it will melt because it is reacting with the water. The sodium floats on the water, as we said before, because it is less dense, so it will not draw into the water. It will not be sunk into the water. Generally, if you add a chemical material or any stone, for example, or any other metal that doesn't react with water, like copper, for example, like iron, you're going to see that the copper or the iron piece of metal is going to be drawn into the water. But as long as we're using sodium, which has less density than water, so it will be floating. 3, the sodium moves rapidly across the water surface, as we said before, because it's less dense and the reaction is a little bit violent. The piece of sodium gets smaller and eventually disappears because it dissolves into the water step by step, and the reaction is like Na, which is solid, will react with H2O, which is liquid, to give NaOH plus H2. I'm not going, so this is the gas, and here we have AQ or aqueous. This means this chemical material will be dissolved in water. I'm not going to balance the equation now because balancing the equation is irrelevant, and we are going to see that there is a hissing sound that will be heard during the reaction. Now, question B. Here, give a test to show that at the end of the reaction, solution contains sodium ions. This is not so much difficult. There we had something called, if you remember, my friends, we have something called chemical tests, and we have tests for positive elements, and then we talked about the fire test, or the flame test, as we called it, the flame test. In here, my friends, we bring a rod. We bring a rod or a wire of platinum or titanium, for example. We dip it into the solution, then we put it on the flame, so that the color will be changed from blue, because generally the flame is blue, because we use Bunsen burner generally. So the flame is blue, but after we burn this soaked wire of platinum or titanium, it will be changed into bright yellow, because this yellow refers to the presence of the sodium ions. Now we move to the next question C here. Lithium, sodium, and potassium. Lithium, sodium, potassium. Here they are in group 1 in the periodic table, my friends. React in a similar way with water. So state with reference the electronic configuration of atoms, why these elements have similar reactions. Generally, they have similar reactions. Of course, if we take into consideration the electronic configurations of these atoms, we should remember that they are in group 1. What do we mean by group 1? All of them are in group 1. Lithium, sodium, potassium, they are in group 1. This means that each one of them has 1 electron in its last shell. For example, this is period 3. We have K and L and M. This is period 4, if I remember. I don't know. Hydrogen, lithium. No, so this is period 2. So we have 3 electrons here. We have 11. I guess we have here 19. If we distribute them over the electronic shells, we will notice that this will be filling K and KL, and in L we have 1 electron. Here we have KLM. In M we have 1 electron. Here we have KLMN. I think this is period 4. In N we have 1 electron. So they have something in common, which is each one of them has 1 electron in its last shell according to the electronic configuration. So as the each element has 1 electron in its outer shell, so they have similar reactions because they have the same number of electrons in their outer shell. Next question, my friends. Deduce the relationship between atomic radius and reactivity of metals, lithium, sodium, and potassium. As we see before, and as we said before, my friends, here we have the lithium has 2 shells. The second one is the outer shell. Here we have for sodium 3. This is the nucleus. This is the nucleus here. Here, nucleus here. And this is shell number 1, shell number 2, shell number 3. You know, we distribute the electrons over shells, and we have the last atom here with 4 shells. So as the radius of the atom increases, we have an increasing here from lithium to sodium to potassium. Of course, potassium should be bigger than sodium, but we didn't have a space to draw it. So the radius increase, as we see here, R, radius increase. So as the radius of the atom increases, the reactivity will be increasing also. And the larger the atomic radius, the more reactive the metal is. So lithium is reactive, but sodium is more reactive and potassium is more reactive, as we see here. So when we go downward into this group, reactivity increases. Now we go to question 5, I guess in a separated video. Thank you for watching this video, my friends, and I hope you understood. See you in the next video.